Welcome back from the ad break, and let's continue with our lesson. So now we are going to move on to that second concept in our concept map, and those are the output values. Remember, we already focused on the input values, so we are going to use those same flow diagrams and the tables just to identify our output values. So let's see what we have here. So when we represent functions, there are input values and output values. So we've already discussed those input values. Let's see what these output values are. So output values, the value that you get out, or the answer, from using a certain input value in an equation or a formula. This value can be represented using any variable. In functions, it is usually a y. So we can see that we are still working with that same equation, y is equals to 2x plus 8, but this time our focus is on the output. So that y is that output, our answer from using our input. So let's look at that first flow diagram that we looked at initially. It says complete the flow diagram below. Use the rule to calculate the output values. So remember, we identified those input values. Let's use our rule to identify the output values. So -6 is the one we start with. We are going to add. So we are going to add our 4. And -6, when we add 4, will give us an answer of -2. That is completely correct. Then we have -1, and when we add 4 to -1, what answer do we get? Well, if you are thinking of a 3, then you are correct. And then what about 11, and we add 4, what answer are we going to get? Yes, the answer is a 15. So those values, they are our output values, the answer. Remember, the result that we get from using the input values there. So if we fill those into our table, when the input value was 6, our answer was -2. When the input value was -1, so when the input value was -6, our answer was a -2. When the input value was a -1, our answer was a 3. And when the input was an 11, our answer was a 15. Let's move over to the other flow diagrams. So in these coming flow diagrams, we are going to do exactly the same. We're going to take the input value, let it go through the rule, and come out with an output value. So -5 multiplied by 7, that will give us an answer of a -35. What about a -3 multiplied by 7? Yes, it is a -21. And what about a 10 multiplied by a 7? Yes. Yes, the answer is a +17. Now let's take those output values and represent them in the input value, in the table. And remember, each output value must be with its corresponding input value. So with -5, our output value was -35. With a -3, our output value was -21. And with a 10, our output value was 70. The next table, we are going to do the same thing, but now remember, there are two things that must happen there. So our input value is going to go through 2 steps or 2 processes. So we have a -7, and we are going to multiply it by 6. Now when we multiply the -7 by 6, that gives us a -42. But we are not done. We are going to continue, and from that -42 subtract a 3. That is going to give us a -45, and that is the output value when the input value is a -7. What about the -2? Well, -2 multiplied by 6 is a -12. And now from that -12, we are going to subtract 3. That is going to give us a -15. What about our 9? Well, when we multiply 6 by 9, we are going to get an answer of 54 actually. So 54 is 9 times 6. And then from that 54, if we subtract 3, we are going to get an answer of 51. So those are the output values. So when our input value was -2, our answer was a -15. And when the input value was a 9, our output value is there a 51. Let's look at the next flow diagram. So here we have, again, 2 steps that our input values are going to go through. Let's write our output values. So -12 divided by 2, that is going to be a -6. Now from that -6, we are going to add 8, and that gives us a +2. So when the input value is a -12, the answer is a +2. What about -6? Well, -6 divided by 2 is a -3. So -6 divided by 2 is a -3, and when we add 8 there, it is going to be a 5 as the answer. Then 20 divided by 2, that is 10. 10 plus 8, that is going to give us 18. So when the input value is 20, the output value is 18. And when the input value is a -6, the output value is a 5. Let's move over to the last concept of our concept map, and that is formula and equation. So we are going to be dealing with formulae and equations. Now, when we are working with formulas and equations, firstly, we already know that when we represent functions, there are input values and output values. So we've seen how these values are represented on flow diagrams and in tables. So these same values can be represented using a formula. In fact, any values, they can be represented using a formula, not just these specific values. So now, we have an equation. Just to remind you, those are 2 expressions that are equal to each other. In this case, this will be the expression for the input values and the expression for the output values. Then the formula is a mathematical relationship or a rule expressed in symbols. So the formula is the rule for the function. The process from the input and results as the output. So that would be the formula. Now, as shown here, we have an input that goes into our rule, and that in turn will produce our output. So having our equation again, y is equals to 2x plus 8. The y is our output, which is the answer, and the x is the input, which is the one that goes into our rule. Let's look at those 4 flow diagrams and see if we can get the rule from those. Well, this first one here is an example where we are going to write down the rule from this flow diagram. Now, for us to get these output values, we already saw that we took the input values, we added 4, and we got the output values. And this is what happened with each of those input values. So what was the rule? Well, the rule was 4 is added to a certain value, and those values were the input values. So now, if we make it more clearer, we could say that the output value, which is the y, is equals to the input value plus 4, because that is what we did in the previous to get those output values. So the formula would be y is equals to x plus 4, or in other words, the output value is equals to the input value plus 4. So that was a simple rule to discover. Let's look at the other rules and see if we can't get them. So next here again, we are writing down the rule for this flow diagram. So now remember, the rule was to multiply by 7. So if we are going to convert this into a formula or an equation, then we need to use the algebraic expressions. So how are we going to represent this? Well, we can see that for us to get the output value, what we did was to take the input value and we multiplied it by 7. Of course, we can simplify this equation or formula by saying that x multiplied by 7 is written as 7x. And that is the formula for this flow diagram. Y is equals to x times 7, or 7x, or the output value is equals to 7 multiplied by the input value. This next one here, remember it had 2 steps that the input value would go through, but we can simply write an equation or a formula for it. That is y is equals to, now what we did was to take the input value, we multiplied it by 6 and we subtracted that 3. So what does this mean? This means that for us to get the output value, we said 6 multiplied by the input value and then we subtracted 3. And that is exactly how we got that formula. Let's look at this last one here. How did we get the output values here? Well, for starters, we took the input values and we divided them by 2. So we took the input values, which are represented by x, and we divided them by 2. And after we divided them by 2, that quotient we took and we added our 8 there. So that would be the formula for this flow diagram. That was a wonderful lesson on input and output. We hope to see you next time for our next lesson. Thank you and goodbye.